Right now, buried under the red dirt of Mars, there might be a beach. Not a pretend beach, a real one with layers of sand that used to feel ocean waves roll over them again and again. That sounds impossible. Mars looks like the driest, most broken place you could ever imagine. Red dust stretches out in every direction. The sky is empty. There are no rivers, no puddles, not one drop of water anywhere you can see with your own eyes. But robots sent millions of miles away just found proof that this dead-looking planet used to be soaking wet. And what they found is stranger than almost anyone expected. Small round rocks that look exactly like blueberries, a thin white rock vein made of the same mineral used to make the walls in your house, and deep underground, a slope that matches a beach on Earth almost perfectly. So how did a planet that looks completely dry end up hiding an ocean underneath it? Stick around, because by the end of this video, you are going to look at Mars in a totally different way. A planet that looks completely dead. If you looked at a photo of Mars right now, you would probably think nothing could ever live there. The ground is a dusty orange-red. The air is so thin you could not breathe it even for a second. Nighttime temperatures can drop so low that carbon dioxide, the gas you breathe out, actually freezes solid and falls like snow. There are no oceans, no rivers, no clouds bringing rain. It looks like it has always been this way, a dead rock spinning quietly through space. But here's the strange part. When scientists studied pictures of the Martian surface taken from space, they noticed something that did not fit. Long, winding paths cut into the rock, branching patterns that looked exactly like something you would see from an airplane flying over a river delta on Earth. Deep canyons with smooth, curved walls, the kind of shape water carves out over millions of years, not the kind of shape wind or dust makes. These shapes were the first clue in what would become one of the biggest mysteries in space science. If water carved these paths, that means water used to flow across Mars a long time ago. And if water was there, that changes everything, because here on Earth, water is one of the most important things every living thing needs to survive. So scientists came up with a simple plan. If they wanted to know whether life ever existed on Mars, the smartest thing to do was not to search randomly across the whole planet. Instead, they needed to follow the water first. Find where water used to be, and you have a much better chance of finding clues about ancient life hiding in the dirt and rock left behind. It is a lot like solving a mystery. You do not start by guessing wildly. You follow the clues one at a time until they lead you somewhere real. And on Mars, the biggest clue of all has always been water. But knowing that water once existed is very different from proving it. Pictures from space can only show so much. To really prove it, scientists needed something on the ground, digging through the dirt, testing the rocks up close. They needed robots. This is where the story gets really interesting, because what these robots dug up over the years is more shocking than most people realize. Small rocks that formed only because of water. Rock layers that match beaches here on Earth almost exactly. And clues about a mystery involving the sun itself that scientists still cannot fully explain. Think about how strange this really is for a second. Mars is not some random empty rock floating out in space. It is a whole planet, almost half the size of Earth, with mountains taller than Mount Everest, and a canyon so long it could stretch across the entire United States. A planet that big does not just lose all its water for no reason. Something happened here. Something big enough to turn a wet, possibly living world into the dry, dusty desert we see today. That is exactly why scientists have spent decades sending robots across millions of kilometers of empty space just to dig through Martian dirt. Every rock they crack open, every layer of dust they drill into, is one more piece of a puzzle nobody has ever fully solved. And piece by piece, that puzzle is starting to come together in ways that are honestly hard to believe. If you want to see exactly how each discovery came together, piece by piece, stick with this video, because it only gets crazier from here. And if this kind of space mystery is something you enjoy, hit subscribe now. This channel breaks down real space discoveries like this one every single week, in a way that is easy to follow and does not drown you in confusing science terms. You will not want to miss what comes next in this story. Meet the robot detectives. To understand how scientists proved Mars once had water, you need to meet the robots that did the actual digging. These are called rovers, and they are basically robotic explorers that drive slowly across the surface of Mars, taking pictures, drilling into rocks, and testing the dirt for clues. Picture a robot about the size of a golf cart, rolling slowly across an empty red desert all alone, with nobody around for millions of kilometers. It cannot call for help if it gets stuck. It cannot ask a question and get an answer back right away, since a single message takes many minutes just to travel between Mars and Earth. Every move it makes has to be planned carefully, because one wrong turn into soft sand could end the entire mission. That is the world these rovers live in. And despite all of that, they have managed to find some of the strangest and most convincing evidence ever collected about another planet. One of the most important rovers in this whole story is a robot named Opportunity. It landed on Mars and was only supposed to work for about 3 months. Instead, it kept going for almost 15 years. slowly rolling across the Martian surface, checking rocks and craters along the way. Early in its journey, Opportunity found something that nobody was expecting. Scattered across the ground were tiny, smooth, round rocks. They were so round and so evenly shaped that scientists nicknamed them blueberries. At first, nobody could explain why they looked like this. It turns out these little round rocks are a big deal. On Earth, rocks like this usually form when water moves slowly through rock over a very long time, depositing minerals bit by bit until they build up into small, round balls, kind of like how a snowball gets bigger and rounder the longer you roll it through snow. Finding thousands of these blueberries scattered across the ground was a strong hint that water had once soaked into this area for a long time. As Opportunity kept exploring, it found even more of these round rocks in different places, and not all of them looked exactly the same. Some were bigger, some were smaller, and some had a completely different mix of minerals inside them. That told scientists something important. These blueberries were not all made in the same event, at the same time, in the same way. Instead, different parts of Mars seemed to have their own separate watery history, almost like different chapters of the same story spread out across the planet. But the blueberries were only the beginning. As Opportunity kept driving, it reached the edge of a giant crater and began climbing along its rim. Along the way, it came across something even stranger, a thin white line running through a rock, almost like a vein running through the ground. When scientists studied this vein up close, they found it was made of a mineral called gypsum. You have probably touched gypsum before without knowing it, since it is one of the main ingredients used to make the drywall inside houses. Gypsum does not just appear out of nowhere. It forms when water dissolves certain minerals out of rock and then carries them somewhere else, where they slowly build up again as the water dries out. Think about a puddle drying up in the sun and leaving a crusty white ring behind. That is basically what happened here, except it happened underground, inside a crack in the Martian rock, a very long time ago. Scientists named this discovery the homestake vein, and it became one of the strongest pieces of proof yet that water had flowed underground on Mars, not just on the surface. What made this even more exciting was what the water might have been like. When scientists studied the vein closely, they realized the water that created it was probably not harsh or acidic, like some of the water found in other parts of Mars. It was closer to neutral, similar to the kind of water you might find in a calm pond here on Earth. And calm, gentle water like that is exactly the kind of environment that living things have a much easier time surviving in. Opportunity was not finished yet. Later in its mission, it reached an area that scientists had been hoping to explore for a long time, a patch where clay might be hiding. Clay might sound boring, but on Mars, clay is treasure. Clay only forms when water sits on top of rock for a very long stretch of time, slowly softening it and changing its chemistry. Rivers and floods move fast. They do not leave much clay behind, because the water rushes through and keeps going. But clay forming means water sat calmly in one place for a long time, almost like a quiet pond, rather than a rushing flood. At this site, which scientists nicknamed Whitewater Lake, Opportunity found a pale-colored rock that turned out to have exactly the clay signature scientists had been hoping for. It was some of the clearest proof yet that Mars once had calm, standing water, not just quick floods that came and went. Scientists spent weeks studying this one rock, testing it over and over to make sure they were not making a mistake. That might sound like overkill for a single rock, but this was one of the most important discoveries of the entire mission, so getting it right mattered more than moving on quickly. Every extra day they spent checking their results was another day making sure this piece of the puzzle actually fit. By the time Opportunity finally went quiet for good, after traveling far longer and far farther than anyone ever expected, it had spent close to 15 years on Mars. In that time, it had built one of the strongest cases ever made that calm, gentle water once existed on the Martian surface. But Opportunity could only explore one small slice of an entire planet. If scientists wanted the full picture, they needed to look somewhere completely different. By the time Opportunity finally stopped working, it had traveled over 50 times farther than anyone originally planned. And it had helped prove something huge. Water had once flowed on Mars, sat calmly in some places, and moved slowly through cracks in the rock in others. But this was only the beginning of the story. A few years later, a very different rover would land in a completely different part of Mars, and it would stumble onto a discovery so strange that it made scientists question everything they thought they understood about this new location, the rock that broke the rules. The next chapter of this story takes place inside a crater called Jezero, a spot scientists picked very carefully because pictures from space suggested it used to be the bottom of a lake, complete with what looked like an old river delta feeding into it. A river delta is the fan-shaped pile of sand and mud that builds up where a river slows down and spreads out. And seeing one frozen in stone on Mars was a huge clue that water had once flowed here for a long time. Out of every spot on the entire planet, this crater looked like one of the best possible places to search for old signs of life. If anything survived on ancient Mars, this seemed like exactly the kind of quiet, water-filled place it might have called home. Landing here was a rover named Perseverance. But Perseverance did not travel alone. It brought a tiny helicopter along with it named Ingenuity, the very first aircraft ever to fly on another planet. Before Perseverance could safely explore certain areas full of sand dunes, scientists needed to know it would not get stuck. Sand dunes on Mars can be dangerous, since a rover that gets its wheels buried in loose sand might never be able to drive out again. So Ingenuity flew ahead first, taking pictures from above to scout out the safest path through the dunes. This was a huge deal on its own. Nobody had ever flown a powered aircraft on another planet before. The air on Mars is so thin, almost 100 times thinner than the air here on Earth, that getting anything to fly at all seemed almost impossible. And yet, this tiny helicopter, weighing less than 2 kilograms, lifted off again and again, buzzing along 10 meters above the dunes, and beaming pictures back down to help guide its much bigger rover partner. With the path mapped out, Perseverance carefully rolled through the dunes and reached a rocky outcrop that scientists were eager to study. Using its drill, it collected small samples of rock to examine closely. What it found completely surprised everyone. Scientists had expected to find sedimentary rock here, the kind of rock that forms slowly from sand and dust settling and pressing together over time, the kind you would expect at the bottom of an old lake. Instead, Perseverance found something called igneous rock, specifically a mineral called olivine. Igneous rock does not form from water or settling sand at all. It forms from melted rock, the kind that comes from volcanoes, cooling down and hardening. Think of it like the difference between a sandcastle built grain by grain on a beach and a chunk of glass that formed when something got so hot it melted and then froze solid again. Two completely different stories, and finding the second kind, deep inside what was supposed to be an old lakebed, did not seem to make sense at first. At first, this felt like bad news. If this spot used to be full of melted volcanic rock, how could it also have been a lake full of water? But the more scientists studied the rock, the more the real picture became clear. The edges of this rock had grooves and worn-down shapes that could only have been carved by moving water, and those marks had formed after the rock had already cooled and hardened. In other words, this area may have had volcanic activity happen first, and only afterward did water flow in and settle on top. And that turned out to be great news, not bad news. Volcanic rock like this is often packed full of minerals, almost like natural fertilizer. When water flows over mineral-rich rock like this, it can create exactly the kind of chemical-rich environment that living things need to get started. So instead of ruining the lake theory, this strange volcanic rock actually strengthened it. It painted a picture of a crater that once had both volcanic activity and moving water, two ingredients that together could have created surprisingly good conditions for life to begin. You can actually see the same pattern here on Earth. Some of the most fertile farmland in the world sits near old volcanoes, because volcanic soil is packed with minerals that help plants grow strong. If mineral-rich volcanic rock could do that much for plants on Earth, it is not a stretch to think it could have given early Martian chemistry a serious boost too, right at a time when this crater also had water flowing through it. Still, this only proved that lakes and puddles had existed here at different points in time. It did not prove anything close to a full ocean. Lakes are exciting, but oceans are a completely different level of evidence, since an ocean would mean Mars once had a massive, long-lasting, connected body of water covering huge parts of the planet. Scientists wanted that kind of proof badly, and on the opposite side of Mars, a completely different rover was quietly gathering the exact kind of evidence that could finally answer that question. A beach buried 1 billion years ago. This next part of the story takes us to a robot named Zhurong, sent by China to a wide, flat region of Mars called Utopia Planitia. Landing a rover safely on Mars is incredibly hard, and pulling it off made this only the second country in history to ever do it successfully after the United States. This area had already caught scientists' attention years earlier, after satellites detected a massive amount of ice buried underground here, enough frozen water to fill a lake as big as one of the Great Lakes on Earth. That much buried ice was already a strong clue that this region had a watery past. But what Zhurong was about to find would turn out to be even bigger than anyone expected. Zhurong carried a special tool called ground-penetrating radar. Think of it like a very advanced version of knocking on a wall to check if there is something hollow behind it. The radar sends signals down into the ground, and whenever those signals hit a spot where the material underground changes, some of the signal bounces back up to the rover. It is a bit like shouting into a canyon and listening to how the echo bounces back to figure out the shape of the walls around you. Except instead of sound, Zhurong was using radio waves, and instead of canyon walls, it was mapping out hidden layers of rock buried far below its wheels. As Zhurong studied the area beneath its wheels, something odd started showing up in the data. Over and over, the signals kept bouncing back at a slanted angle, not flat, not random, but consistently tilted the same direction every single time. Scientists gathered dozens of these tilted signals and realized they were looking at layers of buried rock, all sloping downward in the exact same direction, sitting about 10 to 35 meters below the surface. That might not sound exciting on its own, but here is why it mattered so much. On Earth, this exact kind of tilted, layered pattern shows up in one very specific place: buried beaches. When waves roll in and out along a coastline for thousands of years, they leave behind slanted layers of sediment that all point in the same downhill direction toward the sea. Scientists compared what Zhurong found to real buried beach layers found along the Bay of Bengal here on Earth, and the match was almost eerie. They also ruled out other explanations. Sand dunes do not create slopes that all point the same direction, since wind blows from many directions over time. Neither do lava flows, which spread out unevenly in random patterns. But a beach, shaped by waves, rolling in from one direction over and over, produces exactly this kind of neat, consistent slope. This was the strongest evidence yet, not just for a lake or a puddle, but for an actual coastline, the edge of what could have been a real ocean on ancient Mars. Try to picture it for a second. Long before any of the deserts and craters we see today, this flat, dusty region might have been a shoreline, with actual waves rolling in day after day, year after year for thousands of years, slowly stacking up layer after layer of sand and sediment. Somewhere out past that shoreline, an entire ocean could have stretched out toward the horizon, covering a huge part of the northern half of the planet. And that detail matters more than you might think. Rivers rush water through quickly, which makes it hard for chemicals to settle, mix, and build into anything complex. But along a calm shoreline, with waves gently rolling in and out, the water sticks around much longer. It can concentrate chemicals, help simple molecules bump into each other repeatedly, and create exactly the kind of chemical soup that many scientists believe life needs to get started. In other words, if Mars really did have oceans with real coastlines, it may have had some of the best possible conditions for early life to form. Conditions similar to what many scientists believe helped kickstart life here on Earth billions of years ago. This discovery answered one huge question, but it also opened the door to an even stranger mystery, one that scientists have been arguing about for decades and still cannot fully solve. The mystery no one can solve yet. Here's the problem. Billions of years ago, when all of this water was supposedly flowing across Mars, our sun was actually about 25% dimmer than it is today. That is a huge difference, kind of like turning down a light bulb until the room barely glows instead of shining bright. A sun that dim should not have been able to keep a planet like Mars warm enough for liquid water to exist at all. By all the normal rules, ancient Mars should have been a frozen wasteland, a giant ball of ice sitting far too cold for anything to flow. And yet, all of this evidence, the blueberries, the gypsum vein, the clay, the volcanic rock worn down by water, and now an entire ancient beach, all points toward a planet that clearly had liquid water flowing and pooling for long stretches of time. So how do you explain water existing on a planet that should have been way too cold for it? Scientists call this puzzle the faint young sun paradox, and honestly, nobody has fully solved it yet. There are three main ideas floating around. The first idea is that ancient Mars had a thick blanket of gases in its atmosphere, kind of like a greenhouse, trapping heat close to the surface even though the sun itself was weak. The problem is, when scientists run the numbers, the gases they know Mars likely had are not quite enough to trap that much heat on their own. Something else would have needed to help, and nobody is sure exactly what that something else was. The second idea is that Mars was not warm all the time. Instead, it may have gone through short bursts of extreme heat, triggered by things like massive volcanic eruptions or huge asteroid impacts. These events could have released enough heat and gas to melt ice and create short-term rivers and lakes, almost like sudden heat waves in the middle of a mostly frozen world, lasting maybe a few hundred or a few thousand years before the whole planet cooled back down again. But scientists are not sure these bursts would have happened often enough, or lasted long enough, to carve out all the evidence of water we are finding today. Carving deep canyons and stacking up layer after layer of beach sediment usually takes a lot longer than a few short warm spells could provide. The third idea is that Mars spent most of its history as a frozen, icy world, mostly covered in snow and ice rather than liquid water. Every once in a while, changes in its orbit or sudden bursts of heat could have melted some of that ice, creating short bursts of flowing water before it froze solid again. This would explain signs of both ice and flowing water, but it still leaves the question of what exactly triggered all that melting and how often it happened. Right now, none of these three ideas perfectly explains everything scientists have found. It is a real unsolved mystery, sitting right at the center of everything we know about ancient Mars. And here is the part that makes this whole story even more frustrating. Perseverance, the same rover that found that strange volcanic rock earlier, spent years carefully collecting rock and soil samples across Jezero Crater, sealing them up in special tubes. The original plan was to send a future mission to Mars, grab those sealed samples, and bring them all the way back to Earth, where scientists could study them using far more powerful equipment than anything a rover can carry. One of those samples was even described by NASA as possibly containing the clearest sign of ancient life ever found on Mars. But that return mission ran into a massive problem. Budget cuts threatened to cancel it completely, and while other parts of NASA's funding were eventually saved, the mission to bring these Martian samples home was cut. Right now, those samples are still sitting on Mars, sealed up and waiting, with no confirmed plan or timeline to bring them back to Earth. So the biggest clue of all, the one that might finally answer whether life ever existed on Mars, is sitting alone on a planet tens of millions of kilometers away. And for now, nobody can go get it. Think about that for a moment. After everything these rovers found, the blueberries, the gypsum vein, the clay, the strange volcanic rock, and an entire buried beach, the one sample that might actually prove life once existed is locked inside a sealed tube, sitting quietly in the Martian dust, waiting for a ride home that has no clear date on the calendar. It could be years, it could be decades. Nobody knows for sure, which means this case, the mystery of water and possibly even life on Mars, is still wide open. And that leaves us with a strange kind of ending. Every rover that has ever driven across the Martian surface has pointed toward the same conclusion. Water was here. It pooled in craters, it soaked into clay, it left mineral veins behind, and it may have crashed onto beaches as waves. But the one thing that could turn all of that water evidence into proof of actual life is sitting locked away, out of reach, at least for now. Maybe someday a human explorer will walk across that same ground, pick up that same sealed tube, and finally crack this case wide open. Until then, Mars keeps its biggest secret buried in the dust. If this video blew your mind even a little bit, make sure to like it and hit subscribe and turn on notifications so you never miss the next mystery we dig into. And here is a question for you to answer in the comments. If scientists finally proved that life once existed on Mars, do you think that would change the way people think about life here on Earth? Let me know what you think down below, and if you want to keep exploring strange space mysteries like this one, check out more videos on this channel where we break down the weirdest discoveries in our solar system.